Hi, so let's look at the level 10 Killer Sudoku on dailykillersudoku.com for August 11th, 2021. So this puzzle is definitely interesting. The first things to fill in are going to be these two cages here. And this 8-9 will force this to be a 5-7. This will be an 8-9 and 3-4 like this. 1, 2, 3, 4 here. So I'm going to try to go through this pretty quickly. I've already solved it, but just kind of filling things in here as I go and trying to remember everything that I did. So one of the first keys to this puzzle is going to be this 13 cage. And to solve this 13 cage, what we want to look at is this value here. This is an 18. And this value here is the remainder is 17, and this remainder here for these three cages is 18. So these two relationships are kind of the key to the beginning of this puzzle. So this remainder here is 9, so we have 1, 2, 3, and 6, 7, 8. But as you solve for these, the 1 breaks because of 8, 9. The 2 breaks because of 7, 9. So neither of those is possible. On the opposite side, the same type of thing happens, where the 1 and 2 will both break on this side. So that means this has to be a 3, 6. And then if you try to put a 6 in this cage, that makes this a 12, but there's no way to build the 12. And the reason for that is you can't use 5, 7, and then 3, 4, 8, 9, even though we have the 3, 4, 8, 9 possible here, that would break the 5 cage. So this can never be a 6. So this is going to end up being a 3, 6 like this. And then that makes this an 11. So the only way to make the 11 here will be 2, 3, 8, 9. This is 4, 5, 8, 9 over here. So now we have an 8, 9 pair. So if we go back up here, with the 3, our remainder here is going to be 15. So this has to be 6, 9, 6, 9 like so. And that also forces our 12 cage now to be 4, 8, which also forces the 5 cage, and the 7 cage. So if we look down here at this relationship here, this totals to 95, but we subtract 11. So that actually gives us a remainder here of 6. So this cell has to be 6. And the only way to do that is 1, 5. If we do the exact same thing on the other side of the puzzle here, this is 97 minus 15. So that's going to give us remainder of 8. So the only way to make an 8 here will be 2, 6, because 1, 7, and 3, 5 are both gone here. And then this 6 forces all of our values here. And then the 2 and the 4 get forced out of the 6 cage. So this is 2, 3, 6, 7. So this is a 1, 5 here. The 10 cage, oh right, this forces this also to be a 7, 5, like so. The 10 cage, sorry, I have combos on. This is now a remainder of 7. So the only way to solve that will be with 1, 6. So the 6 will be here and the 1 will be here because of the 1, 5. And now our 1 is going to be locked in down here. We have a remainder here of 2, 3, 6. The 2 and the 6 are both gone here. So now if we come back down to this box, the next thing with this puzzle is looking at this combination here. So this is a total of 30 plus 7 plus 6. So that total is 43. The only values left are 2, 3, 6, and 9, right? So because we have 43 as our total, the 2 won't work because that totals us to 45. So, and the 3 won't work because that would require 1. The 6 here would be a total of 4, but that's not possible because of this 4. So this has to be a 9, and this will be a 7. And then our remainder here is 2, 3, 4. And our 9 goes away here. Our 5 will always be in one of these 2 cages. Our 9 will be in one of these 3. And then, so now if we go back over to this side of the puzzle here, so here we have a total of 31, plus 8 is 39. And when we do the math here, if we put a 1 in this cage, the puzzle starts to break down. Because if you put a 1 here, so actually I'll just fill in the values here, 1, 3, 5, 7, and 8. So these are the only possible values left. If this is a 1, the 33 cage can never have a 1 in it. So once again, so if this is a 1, this would be a 5. And so based off of that, I have to think about this one for a second. Yeah, so if this is a 1, then we're at 40. So the only thing we can use will be the 7 or the 8. The 7 will make this a 2, and the 8 will make this a 3, but we can't use a 3 because that's burned. So this would be a 7 and a 2. And this will be a 5. Oh, right, so I didn't fill in this other side. So because this is a 4, this forces this to be a 4, 7. This is 1, 2, 9, and 5. And up here we have 2, 3, or 2, 5, 8, 9. So the 17 cage can never be 8 and 9. And we also have the 8, 9 down here. So an 8 or a 9 has to be in the 17 cage because it can't be 2, 5. So because of that, we have an 8, 9 pair between the two 17 cages, forcing this to be a 2, 5. So when we do this solve with the 1, and if this is a 7, this has to be a 2, but this has to be a 5, and that breaks because of the 2, 5 pair. So this value must be a 5. So now we're left with 3, 7, or 8, and because this is a 5, we're now at 44. And if this is a 3, this is a 2, and if this is a 7, this is a 6, or a 7. So now we have a 2, 6, 7 here. But if this is an 8 and this is a 7, the 33 cage breaks. The 33 cage must contain a 7, 8, and a 9. But if this is a 7 and this is an 8, there's no place to put the 7. So this can never be an 8, and this can never be a 7. So now we're left with the 3, 7, and 2, 6. And that also gives us a 2, 6 pair inside of this box. So let's look over here again. Oh, right, this can't be a 5. Up here we have 1, 3, or 9. It can't be a 2 because the 2 will be in column 9. So this is a 1, 3, 9. And then here, with this relationship, so the question is how do we add up to 17? So it'll be 2, 8, which is 10 and 7, or 2, 9, 6, 3, 5, 3, 5, 9, which will equal 17 also, won't work because the 3 and the 9 will break column 7. So this can never be a 3. So it has to be a 6 or a 7, and the 5 never comes into the equation here. So this is going to have to be a 5 here. So we always have a 2 in one of these two cages. We also have the 6 must always be here in this row. The 7 must also be in this column, sorry. So in this column we have a 6 and a 7. And then if we do the calculation that says, okay, what if this is 6, 2, 9? Then that will actually force these two cells to become 7 and 8. So if this is 6 and this is 2, 9, this will become an 8, this will become a 9. But we have to have a 7 and 8 still. So the 7 and 8 will go here. But the problem with that becomes this cell down here. Because this is a 6, this makes this a 9, and this makes this a 6, which also makes this a 2 and a 3. So this is 2, 3, and 6, but 7, 8, and 9 have to be represented in this box, but this cell will have to be a 9 because the 9 can't go here because it's here, and the 9 will never be here because it's in one of these two. Oh, sorry, it's already used over here. So that forces this to be a 7, 8, but this cell here will have to be 7, 8. So this can never be a 6. So this is going to be 7, 2, 8. And then this is going to be 6, 9, and 1, 3. So it can't be a 1, 3 here. So let's just put all the values in. So this gives us a 6, 9 pair, actually, which forces this to be a 2. Oh, right, the 1 here forces our 1 to be in this cell. So here we have 7, 8 remainder, 7, 8 remainder. Oh, right, and this 2 forces us as well. So this is now going to be a 3. And this also forces this to be 3, 6, which forces our 2 here. We have 3, 6, 3, 6 here. Our 6 will be in one of these two cages or cells. So we're always going to have a 7 and an 8 in these 3 cages. We talked about that earlier. So now we get into the question of what are our remainder cells. So here we have 7, 8, 9, and 4, 5. So the 33 cage, 7 plus 8 plus 9 is 24, giving us a remainder of 9. So if there's a 3, there must be a 6. So that means that this has to be a 6, and then our 9 will be in one of these 3 cages, and we know it can't be here. So that actually fills in a bunch of values for us. And this becomes a 9. This is a 4, 5 now. And then we can now solve the 9 cage here. It can't be 3, 6 because that would break here. It can't be a 4, 5, and it can't be a 2, 7. So this has to be 1, 8. And then here we have a 1, 5 pair. So but this has to be 5, and this has to be the 1, if I could type. this can no longer be an 8, so this is our 7. This is going to be a 4 and a 2. So in this guy here, we have 3, 4, 7, 8. The 3 and the 8 are gone here. 3's gone from here. Our 4 could be along here. Yeah, we actually have a 4-8 pair here, so this can only be a 4-8, and this can only be a 4-9. And the other thing that I finally found for the first time in, well, maybe not the first time, but it's very rare to find an XY wing inside of a level 10 killer Sudoku, or inside a killer Sudoku at all. So we actually have an XY wing here. And what that means is that this value cannot be a 9. So, and that actually forces our 9 into the 33 cage. Now, I probably didn't need to do that, but I found it pretty cool because I was like, oh, I found an XY wing. So, because of that, you can kind of solve a little bit faster. So this is a 4-5 pair, which makes this our 7. And then, can this be a 6? That would actually make this 13, but there's no way to make 11. So this can never be a 6. Same thing's going to happen here with the 4, because you're going to need a bigger value. So this is only a 4-5 remainder. So this is actually going to be 7-9. And then that gives us a remainder of 8. So this has to be 3 and 5. So, I mean, if you saw something that I missed, which is pretty likely for me because I'm flitting all over the place here, but, you know, I think the key to this puzzle was really trying to figure out the values up here, and maybe a couple other minor keys around. So there you go. So, you know, a shortened version of this, maybe not a summary video, but I think there were some pretty educational parts of this video. I hope you found the same, and if you did, please like this video and subscribe to my channel. Thanks.